we now demonstrate how to use SPSS to run multiple regression with dummy variables. So far, we have used Excel to run ANOVA, simple regression, and multiple regression. Although Excel is a very powerful tool, I have to say that SPSS is a more powerful statistics software. So we are going to start use SPSS for this module because some of the function cannot be run easily in Excel. So let's open the file we want to run in SPSS. So we open the file of the M5L1 heating cost case with dummy variables and interaction. I already saved the file in the format of SPSS, so you can open it directly. So let's say OK. From here, we can see that we have the variable cost, temperature, installation, age, and garage. The garage is in the categorical form, so we must transfer it into a numerical dummy variable. Typically will be in 0 or 1, right? To do so, we are going to call the transform, find the create dummy variables. One more time, transform, create dummy variables, and we say OK. So we have the garage into the right column, and we create a new name for these new dummy variables. We call garage D. And we say OK. OK, this SPSS workbook tells us that it already created 2 dummy variables for us. So let's go to the data directly, and we can see these 2 new dummy variables. Okay. If you look at closely, you can find that the value of D2 is 0 and D1 is 1. And when D2 is 1, D1 is 0. So basically, these 2 values are opposite to each other. Because we have only 2 levels for the categorical variable garage, we just need 1 dummy variable for our analysis. In other words, one of the dummy variables is redundant for us in this analysis. So we want to pick one of them, okay? In this analysis, I will pick dummy variable 2. The reason is it's just my personal preference. I like to use 0 for no and 1 for yes. By the way, before we go to the analysis, you can see that we have 2 decimals for the 1.00, right? For these dummy variables. We don't need those decimals, so we can go to the variable view, and you can see these 2 new variables. In the decimals, here you can change it to 0, and that's it, okay? As you can see that in this variable view, you can also change the type and some details of other variables. You can play with it later. Okay, now let's go to the data view. And we can call the analyze, okay, analyze, find regression, and linear. Okay, one more time, analyze, regression, linear. And this will give us the multiple regression module. Here, cost will be our dependent variables. So we can just say yes for the cost to be the dependent variable. We have the temperature and installation, right? And age. This will be our independent variable. So we pick into our independent variable. However, we have 3 more independent variables here. First one is categorical variable. We cannot use that directly. So all we can do is to pick one of the dummy variable. I already said that I'm going to use the dummy variable garage Y, the dummy variable 2. So I'm going to pick this one. And either one is fine. If you pick the other one, actually, you are going to have the same goodness of fit for the entire model. You have the same coefficients for other independent variables. The only thing difference is the coefficient for the dummy variable 1 will be different from the coefficient of the dummy variable 2. Specifically, the coefficient for these two dummy variables will be opposite to each other, okay? Because they are opposite to each other in terms of value. So now let's include the garage Y into our independent variable as well. Now we have the temperature, insulation, age, and dummy variable 2 of the garage in the independent variables columns. Theoretically, we can change the options of the multiple regression, because we don't need them for now. So we just say, okay, and take the default settings. Okay, so we say, okay. In the output, you can see the model summary for the multiple regression model. Overall, we have 84.8% of the variation of the dependent variable can be explained by our independent variables. The ANOVA table tells us that the goodness of the fit for the entire model is very good. The p-value is less than 0.001, which is less than 0.05, right? So this entire model is very good in terms of goodness of fit. Now let's look at the coefficients table. The first one, temperature, is less than 0.01, which is significant. It tells us that the temperature has a statistically significant impact on the dependent variable. The insulation is 0.01, also less than 0.05. So it means the insulation is also critical to reduce the cost for the heating cost for the house. The age has a p-value of 0.27, which is larger than 0.05. It tells us that the impact of the age on the dependent variable cost is not statistically significant. The garage dummy variable has a p-value of 0.007, which is less than 0.05. So again, it tells us that the impact of the garage on the heating cost is statistically significant. So this just shows us that overall we have a nice output for the multiple linear regression. Okay, so this demonstrates how to use and include dummy variables into the multiple regression model using SPSS. Okay, thank you.